everyone. My name is Milam, and welcome to my very first video for my new channel slash series that's going to serve as the video companion for the book Hands-on Machine Learning with Scikit-Learning and TensorFlow. If you're not familiar with this book, Hands-on Machine Learning with Scikit-Learning and TensorFlow, this book is meant to help you gain intuition and understanding machine learning systems without getting too much into the theory side of things. I've recently started learning machine learning, maybe about 4 or 5 months ago, and I've done that primarily through Stanford's free online Intro to Machine Learning course. But I've also been using this book for its more practical approach to machine learning. And so I created this channel to kind of affirm what I know for myself, but also to teach you as I learn and also get some practice with some of the more practical approaches or applications to machine learning. And so the plan for this series is to create a video for every chapter in the book and do a project for each of the themes that are presented in that chapter of the book. And so I'm going to be doing a couple of things differently. One is I'm going to be doing, so in the book, they have kind of exercises for each of the concepts that are presented in the book. I think maybe chapter 2 was the only chapter where they actually do a full-blown project, but for the most part, rest of them are pretty much exercises. And so what I actually plan on doing is doing a project for each chapter in the book for each of the concepts, and hopefully having a deployable app that'll be able to show some of the work that we've done for each of those chapters. And two, I think in the book, they deliberately skip over a lot of the theory behind some of the machine learning models and algorithms. And so I'm going to attempt to dive into that a bit more, and you'll see that in the next video that goes over chapter 2. I think a lot of times it helps you understand what's happening under the hood and how to know, what happened, what went wrong. It just gives you a little bit more context that really helps you grasp some of these complex concepts that come up a lot in machine learning. And so for this specific particular chapter or video, I'm going to be focusing on chapter 1, which is what is machine learning. So I'm going to be talking about what it actually is, why we use it. And then towards the end, I'm going to go through creating a conda environment and going through installing the requirements and stuff to get us ready for the next video where we're going to basically be doing the project. So with that being said, let's get into it. So machine learning is really, I'd like to describe as the science and mathematics of programming computers so they can learn from data without being explicitly told what to do. And so some examples of machine learning that I don't think were super clear to me before reading this book and also starting this course, this Intro to Machine Learning course, is that machine learning is used to detect tumors in brain or breast scans, classify text like news articles or tweets, right? Machine learning can be used to flag a tweet as a hate tweet or something that's offensive. If you've ever played video games and you're going against, a bot, that uses machine learning. Anytime you're seeing forecasts for something like, your company's revenue for next year, that's using machine learning. If you've ever received a text from your credit card or bank that says, hey, this looks like possible fraud, that's using machine learning. In your email to detect spam, that's a really common example that uses machine learning. If you're ever getting emails from a company that you've maybe purchased something from and they are recommending you new products that they think you'll like, that's using machine learning. I think it's really cool because as you'll kind of see throughout this course, machine learning at its core and all of the stuff that we're seeing, whether it's recommendations from a company, detecting credit card fraud, classifying tweets, it's just math, which I think is really cool and maybe was not super obvious to me before starting this course or reading this book. And so there's a few different ways that you can kind of group machine learning systems. And the first is how they learn from data. And so there's four main types, which will be really important to distinguish, given your data, what model or algorithm you should be using, right? So the first group I would say is supervised learning. Supervised learning is basically when you're training your machine learning model, the data that you give it includes the desired solution, and these are called labels. So imagine you have, let's say you want to create a machine learning model that's going to predict the value of the value of a house, right? And so let's say this data is in some sort of CSV file, right? When you're training that model, that CSV file is going to have the actual value of all of your data. So if you're trying to train your model to accurately predict housing values in Miami, Florida, for example, you're going to feed the training data with actual homes from Miami and their listing value, right? And so on the other side of machine learning systems, there's supervised learning, but there's also unsupervised learning, which is basically the opposite, right? And so this is considered unlabeled training data because there is no actual solution in this training data. What your model's job is to try to learn patterns on its own of what's happening in this data. And I think a really common example of this is um, clustering. So if a clothing company or something wants to make its marketing campaigns or its marketing emails more personalized to gain more traction, they might submit a data set with all of its customers. And basically, the model's job is to try to find patterns of what's happening. What are the demographics of the people that come into your stores and what do they buy, right? And so there won't be any solution in that data set. Basically, the model has to kind of find patterns and solutions on its own. The next one would be semi-supervised learning, which is a mixture of both supervised and unsupervised learning. And it really boils down to the fact that data is super messy and a lot of times incomplete. And so you might have a data set where, half of the rows in the data set, right, have a desired solution or label, and then maybe another half doesn't, or maybe there's a bunch of errors in the data where you have to get rid of some of the solutions, which is super common in messy data. And so semi-supervised learning machine learning systems can work with data that's only partially labeled. And then finally there's reinforcement learning, which I think the book described as a completely different beast. And reinforcement learning models or machine learning systems, the learning system is called an agent, and it lives in an environment where it takes actions and it gets rewards or penalties if it does the right thing or if it doesn't, right? And so over time, this model has to figure out the best strategy to maximize its own reward, right? It has to find the best strategy on its own, to maximize its reward. And that strategy is called a policy. And this is super common in those bots you might face in video games, like I mentioned before. And then lastly, there's another way that you can categorize machine learning systems, and it's basically defined by if they can learn on the fly. The first one being batch learning, where this basically means that the system can't learn incrementally. It has to be trained on all of the available data at once. And this is really common because in the real world, you're dealing with massive terabytes of data that can take, gigabytes or terabytes of data that can take a lot of time and computing power. And so it has to basically be done offline and has to train first. Then you can launch your model or the results of your model into production, however you're planning to use it. This is also typically referred to as offline learning. And then another type of learning. So if you can't learn on the fly, the other type has to be learning on the fly, right? And so this is called online learning. And you train the system to train on data incrementally. So you're feeding it data one at a time, one instance at a time, I should say, in small groups, and these small groups are called mini batches. Um, each learning set, excuse me, each learning step, I should say, is fast and cheap, so the system can keep learning on new data as it arrives. And so this, I think, a really good example of this is like stock prices, right? Like when you have trades that or recommendation for trades or trades that happen automatically, right? Um, it has to be able to be really responsive to data that's coming in live. Um, I think machine learning, the way I've maybe described it, sounds really powerful, and because I've done this at such a high level, probably sounds super easy to conquer. But the reality is, in practice, um, your problems from dealing with machine learning will probably come from two places, right? Which is bad data and or bad models, and that's one of the cool challenges of working with ML, especially today where a lot of the models are kind of written for you and you just have to use a package. But a lot of the times the model's failing because of bad data or bad feature engineering on the data, or not enough feature engineering on the data. But also it can just be not the right model that you need to use, or maybe you need a more powerful model. I think that is another common example. Bad data can look like not enough data, poor quality of data, right? Mentioning the semi-supervised learning, right? A lot of times you're going to be dealing with data that's missing, has erroneous values, or not even representative of what you're even trying to solve, right? So let's say you're trying to predict housing data in the United States, but you only have housing data that comes from Virginia, right? And so it's going to be really hard to predict housing data in the United States if your data, your training data, right, only comes from one state. Um, and on the model side of things, I think the two classic failure modes that were described in the book is overfitting and underfitting. Overfitting is often known as high variance, which means that your model is basically just memorizing the training data, instead of learning its general patterns. And underfitting means that it's basically just too general, like it can't figure out what's going on. Um, and so, with that being said, um, let's get into the um, installing the conda environment. So I'm gonna go on my terminal, and I already have an environment, but I'm gonna create a new one that's called. So I'm gonna do right now. I'm in another environment called base. I'm gonna do conda activate, right, and then I'm gonna create another environment, and um so just for, I guess, a bit of a spoiler, um the project in chapter 2 is going to be dealing with Airbnb data. Um, um, but we can call this hands on ML. I already have a hands on ML environment, so I'm just going to call this 2. And then I'm going to say Python is equal to 3.14.4. I'm only doing this because I already have this is the environment that I have for the project that we're going to be going through. And so I think if you leave it blank, it just goes to whatever's the most recent, probably the most recent stable version, which I probably imagine is probably somewhere around this because I did not download this too long ago. Um, but yeah, let's see. And then I'm gonna say, can I copy this? I'm gonna say conda. Oh, they gave it to me actually, so I'm gonna just copy this. to activate the environment. And then I'm going to cd into my project. I think it should be documents, projects, chapter 2, hands-on machine learning, starter. And then, so I'm going to leave a link in the description of the project that's on GitHub, and you can clone that. And whenever you clone that, you can see into that. And then what you can do to install the requirements.txt, just so that way we can start the next project, diving right into it. I'm going to do pip install -r requirements.txt. Let's see. Awesome. Looks like this is working. Awesome. Now, next video is going to be going through chapter 2, which is going to basically be our first machine learning project. So yeah, thanks for watching this, and I'll see you in the next one.